Hello, my name is Javarian Hurd,
Hello, I'm Javon Anderson.
And my name is Ryan Hooks.
and today we'll be discussing the TXY diagram and the PXY diagram. And Javon's going to show you what the TXY diagram looks like.
Okay, I'm finna draw the TXY diagram.
So he starts off with the TXY diagram by basically drawing a graph. And in the TXY diagram is going to basically have a constant pressure, and it's going to show how as the temperature changes, how the phases will change within the whatever the mixture is. So as we said, we have the temperature line right here and the XY line right here, and he's going to draw each individual thing inside the graph. Talk about it.
Okay,
You got it?
yeah, so what I'm drawing now is the TXY diagram. Right here you have your temperature, and then right here you have your mole fractions, so your component of it, and it's all the way to 1. So we're going to draw the VLE.
And for those who don't know what VLE stands for, vapor liquid equilibrium. And this could also be known as a coexistent phase.
In a diagram like this, you have the two phases, which is a liquid phase at the bottom, and at the top you have your vapor phase. And
This is the bubble point. That is the dew point. What is the line called that connects both of them?
The equilibrium tie line.
Yes.
So just draw it right here. We just estimated. And then we have the superheated.
the tie line, bro, it's like this. It just goes from inside to
Oh,
inside.
okay.
It's just inside of there.
All right. Then it's the superheated.
This is super cool.
Super cool.
And then at the bottom of it, you'll have the individual numbers. Like you'll go from, for the X and Y coordinates, you'll go from 0 to 1. And you'll just have points in between. And the temperature, it can depend on whatever the mixture is. It can be whatever the chart you want it to be. So for example, like a diagram like this will have two different substances. It will have, at this point right here, it will have 100% of one substance. And at this point right here, it will have 100% of another substance. And the XY coordinates at the bottom basically shows the percentage of each individual thing that basically the substance has inside of it. Another thing with these diagrams is that it has a point where it can be super cool, like they said earlier, and at the top it will actually.
Okay, so I'm fit to draw the
PXY.
PXY diagram with the azeotrope.
So just like the last one, he draws the same graph, but instead of the T being right here for temperature, it's going to have a P for pressure.
And the temperature is constant.
Exactly, the temperature is constant in this diagram. So right here, it would be a P. X1 and Y1. Well, it could be X in between. It don't matter.
Okay. So one right here.
So it's upside down, basically upside down U. Other way. That's the other way. So we're basing ours off an example between a mixture of chloroform and methanol. It's not drawn to scale, but it's the example that we're referring to. There we go.
Okay, so this right here is your coexistence phase.
This diagram does have a lot of different points that we're gonna individually point out as Jerron draws it on the board.
This the azeotrope.
Yep, at the top we have the azeotrope, and basically with the azeotrope, that's the point where as you change the pressure of the substance, it will go straight from a vapor to a liquid without going to the coexistent phase. And at that point, it is something that is very hard to get to. Once you get to that point, if you change the pressure, it will still be at that same azeotrope where it's stuck at that same individual temperature.
This is your boiling point.
No, the
Boiling curve.
Okay.
Boiling curve.
boiling. This is your dew curve.
And what's in the middle right here?
Your coexistent phase.
And then these are pretty much, this right here, this X1 side and this Y1 side. This is pretty much the composition of the liquid. So this is the boiling point of one substance, and this is the boiling point of another substance when you have two in a binary mixture for VLE.
Great, great. And at the bottom right here, for example, our substance, it'll be a 0 right here, go from 0 to 1, like the last diagram, and it basically determines the how much of each the substance is in at that particular point. And at the bottom right here, for this substance right here, this will be your boiling point at this substance. And if you go over here, this is your boiling point for the other substance. So it depends on the substance where the boiling point will lie at, and these will be your points where it boils at.
And that is the PXY
You
diagram.
say temperature is constant?
Yeah.
And the temperature is constant on the
Right,
diagram.
at the beginning.
Oh,